Hello all, I've just been testing my dad's Lowrance HDS 10. We can't get it to turn on, so we suspect there's a power fault. So I just started testing and it's not looking good. The unit looked right, but a lot of the cable's down. Well, to test the leads, basically what you need is a multimeter. Take the lead from the boot, what I've done here. I've gone further, so I've already cut the fuse off and pulled out the boot. But this is how you test the lead. Basically get your multimeter and turn it to ohms. See that look like a horseshoe? That's the ohm button or setting. Get your leads and touch them together to prove it, and that's 2.6 ohms. So that's proving your integrity of your leads, and there's 2.6 ohms in between them. Well, if you look at the Lowrance plug, them two bottom pins, the largest ones, are your positive and negative. Don't know where you can see that. You can see that pretty good there, can't you? So that's your negative and positive. So they're the ones we'll be testing to prove or why the HDS isn't turning on. Well, I'll now show you how to test the cables. Just for an easy one, I'll do a basic drawing. So that's the plug with the two power pins. And then we've got the cable in the bottom, come from the bottom, obviously the two conductors. We'll say that's the black one, what's negative, and that's the red one, what's positive. Firstly, I'll get the negative crocodile clip and I'll put it on the black cable. I'll go to the plug, I'll go to the left hand side, and that come 3.7 ohms. I'll go to the right hand side, and that's 10 meg, so that's open circuit. So that must make that one the negative pin. Because obviously between there and there was only 4 ohms, and you think the test leads have got 2 or 3 ohm resistance on their own, so that's only an ohm. So that's good, that's got continuity. And obviously between the other side is 10 meg ohm, so that's open circuit. So now I'll put the crocodile clip on the red, the positive lead, and I'll go to the right hand pin. Oh, that's not right. I'm getting over half a meg between the positive and the right hand pin. So between there and there is over 0.5 meg ohms. Well, that's far too much. That should be like that one, about 4 ohms. So obviously there's an issue between that red cable and that right hand pin. Well, we'll then check for integrity between the two. That'll check the insulation resistance. So what I'll do, I'll leave it on the positive and I'll go to the negative side. Oh, we've got 1.5 meg ohm. That's borderline open circuit, but it ain't quite right. So not only is there a issue in the phase there, there's an issue between the two pins. So what I did, this lead should be 3 foot long, and I've cut it back in case there was an issue with insulation breaking down, any cuts or knocks or anything, but it all looked good. All that outer insulation looked fine, but to have a problem in the supply on the positive and an issue between the two, I suspect water has got in the back of that plug and corroded in between the pins in the back of the plug. So that'll allow for the open supply, or the open circuit, and the short. So I think that's had it inside the plug. So I just told my dad we ordered a new lead, and that should be in another couple of days. And the only thing I've got to do is, this is for NMEA output. Obviously with the HDS, we can then put this plug on here, and I plug it into the Icom VHF, so that give lat and long positions on the VHF. So that basically gives us GPS signal. So all I've got to do when the new lead arrive is unsolder this plug, strip it back, and I'll solder this plug back on the NMEA output cable, so then we can link it in with a VHF in future. Well, that is simple that was really, as a basic issue, and hope no one else have it, but that's how you test a power side. Ever so simple. Alright, and cheers for watching. Hope it's been some use. Thank you. Catch you later. Bye.